For this example, we are given rectangular coordinates and we want to find polar coordinates that would match the position for the given rectangular coordinates. So that means that we need to try and figure out the value of r and theta that would put us in the same position as 5, negative 5 rad 3. Now, in order to do this and try and be more accurate, we should probably first plot this point, just roughly plot this point, so that we get a sense of where it is, what quadrant it is in. So let's take a look at this here. So 5 is a positive x value, and then negative 5 rad 3 is a negative y value. So that means that we're going to be in the fourth quadrant. So positive 5, negative 5 rad 3. So we're going to have a point. Let's make that point black, actually. This point here. This is going to be our point. So we want to try and find a value of r and an angle measure that will put us at this same position. So to find the value of r, we can just construct a right triangle here. Construct a right triangle. So where the distance, because remember the r is just the distance from the pole to our point. So this is r here. We know that the horizontal distance here is 5, and we know the vertical distance is negative 5 rad 3. So to find the value of r, we can just use Pythagorean theorem. So r squared is equal to 5 squared plus 5 rad 3 quantity squared. So that's 25 plus 75 is r squared. So r is just the square root of 100, which is 10. So the value of r here is 10. And we just, again, use Pythagorean theorem and the fact that we knew the horizontal and vertical distance based on the coordinates here. Next, we want to try and find theta. So we found r. R is 10. For theta, we have to use the relationships that we know here. So this is theta, to try and find its value. So we know that theta is in quadrant 4, and we're only going to look for angle measures in quadrant 4. But we can use the tangent. So we know that theta is equal to the inverse, or sorry, we know that the tangent of theta, whoops, this is in quadrant 4. So we know that the tangent of our angle theta is equal to negative 5 rad 3 divided by 5, which reduces to just be negative rad 3. And again, we're looking for angles in the fourth quadrant. So here we can take the inverse tangent of both sides. So we get that theta inverse tangent. Inverse tangent of both of these. So we get that theta is equal to the inverse tangent of negative rad 3. Now, normally, when we're evaluating an inverse, it's going to give us a negative angle, which would be what we would get if we traveled in the clockwise direction here. But we could also take the positive angle measure. Both of them are coterminal and would put us in the same position. So we don't have the same restrictions that we do when we are dealing with the inverse normally. So theta could be, what is this? 5 pi over 3. 5 pi over 3. Or we could talk about it as being negative pi over 3. So either of those are acceptable. I would actually take either of those as a valid answer. So if we're trying to write these in rectangular coordinates in polar coordinates, we're going to take the r value, which is 10, and then we're going to pick one of these two. It doesn't really matter to me. So 10, I'm going to use the positive angle measure just because we usually prefer, I think, positive angle measures. So 10, 5 pi over 3, or if you were really wanting to, you could have said 10 and negative pi over 3. Either of those would work. And actually, we could have picked another angle that would be coterminal to either of those as well. But we do have to have an R value of 10.